can I have the presenter? I assign to the first question TG2, T6. If any one of you having lectures in another course, you can go ahead, you can leave.
Yes, doctor, I'm here.
Okay, good. Okay. Okay, can you start now?
Okay. Can you see my screen?
Yes.
Okay, so here is the presentation, right?
Presentation.
Presentation, sorry. Okay, so I will start now. Good morning, Dr. Ao and my fellow classmates. I'm Chilam from TG2 T6, and now I'm going to present tutorial for questions 1A. These are multiple choice questions. A contractor finished a bridge across a lake 18 months early and received more than 6 million for the early completions. This is an example of reducing project duration caused by A. Imposed project durations, B. The market, C. Project delays, D. High overhead, E. Incentive contracts. Before we proceed to the answer, let's see some explanation on each selection. The first one, imposed project durations. The project duration is set while the project is in its conceptual phase, before or without any detailed scheduling of all the activities in the project. The market. The company must spot new opportunities, launch project team, and bring new products or services to the market in a flash to success in intense global competitions. So what is a project delay? A project delay is an unforeseen delays. For example, adverse weather, design flaws, and equipment breakdown which can cause substantial delays midway in the project. High overhead, which means that the direct cost incurred for the shortening the critical path is less than the overhead cost savings. The last one, incentive contracts. The incentive contracts can reduce the project durations and reward both project contractors and the owner. So the answer is very clear, which is incentive contracts. As a contractor who finished the bridge earlier received more than 6 million as incentive for the early completions. Therefore, the answer is E, incentive contracts. That's all for my presentations. Thank you very much. Presentation. Thank you very much, and I will pass my session to the next person.
Okay, very good.
Can you see my screen?
No. Yeah, I can see now.
Okay, good morning, Dr. Ao and all my friends here. I'm Lian from Tutorial Group 2, Team 6. And I'm going to present Tutorial 4, Question 1B. So first, let us read the questions. Adverse weather, design flow, and equipment breakdown can create negative slack. This is an example of reducing project duration caused by. There are 5 options for these questions. A. Imposed project durations. B. The market. C. Project delays. D. High overhead. And E. Incentive contracts. So to solve these questions, we can find the keyword in the question. So what's the keyword in these questions? The keyword in this question is create negative slack. What is negative slack? Negative slack is the amount of time beyond a project's scheduled completion that a task within the project requires, which it means project delay. So to solve this delay, actions are needed to reduce the project duration. From here, we can see the answer is C, project delays. So thank you. That's all for my presentation. And I would like to pass the section to the next person. Thank you.
Yeah, okay, good. Next.
Hello.
Yeah, yes.
Can you hear me?
Yeah.
Okay. Hello and greetings to Doctor and everyone here. My name is Sumaira. I am from Tutorial 3, Group 6, and I'll be answering Tutorial 4, Question 1C. So the question asks, which of the following is not considered a project indirect cost? So A is supervision, B consultant, C equipment, D interest, All of these are considered project indirect costs. So to answer this question, we need to know what are indirect and direct costs. So indirect costs are costs that cannot be associated with any particular work package or project activity. While direct costs are normal costs that can be assigned directly to a specific work package or project activity. So we know that supervision is an indirect cost. Consultants is an indirect cost. Equipment is a direct cost. Interest is an indirect cost. And since E said that all of these are considered project indirect costs, it is false since C is direct cost. So the answer is C, equipment. So that's it for me. Thank you.
Yeah, okay, good. Okay, next.
Okay, good morning, Dr. Au. Can you see my screen?
Yes.
Okay. Good morning, Dr. Au and my fellow friends. I am Ui Sing Teng from Tutorial Group 3, Team 6. I am going to present question 1D. And activities crash costs include which costs? A, direct, B, indirect, C, overhead, D, both direct and indirect, E, all direct, indirect, and overhead. So, in order to answer this question, we need to know the keywords. The keywords here is crash cost. So, what is crash cost? Crash cost is the direct cost for completing an activity in its crash time. It can be used to construct the time duration graph for an activity. And the keyword here is direct cost. Sorry. So this shows us that the answer is A, direct, and activities crash costs include direct costs. That's all from me. Thank you.
Yeah, okay, good. Okay, next. Question 2, TG5, T3. Is the presenter here? If no, can we proceed to the next question? Question 3, TG4, T4.
Yeah. Hello, doctor. Can you see my screen?
Yes.
Okay. Good morning to Dr. Au and all my fellow friends. My name is Corey Young and I am from TG4, G4. I will be presenting tutorial 4, question 3. So there are 4 true-false questions in this question 3. So the first one is crashing critical activity as soon as a problem is detected is the best strategy to take to avoid project delay. The answer is true because when we detect a problem, we need to crash a critical activity as soon as possible.
Can you show your answer? This is still the first slide.
Okay. Can you see?
Yes.
Oh, sorry. Okay, next. The total cost for each possible duration of a project is the sum of labor, materials, and equipment. And this statement is false because the total cost of a project is direct cost and indirect cost. And the sum of labor, materials, and equipment is under the direct cost. Next. Sometimes an activity that is more expensive to crash should be crashed because it is less risky to crash than the cheaper one. And the answer is true. And D, the accuracy of crash times and cost is frequently rough at best when compared with normal time and cost. And this is true because when we predict the crash time, we usually make it the best under the limited resource. And that's all from me. Thank you.
Yeah, okay, correct answers. Okay. Okay, can I have the next one? Question 4.
Can you hear me?
Yes.
Can you see my slide?
Yes.
Okay. Good morning to Dr. Au and my friends. My name is Nurul Izzah binti Razali. I am from TG4T5. I'll be presenting on tutorial 4, question 4. So the question is, assume the network and data that follow, compute the total direct cost for each project duration. If the indirect cost for each project duration are $400 for 19 time units, $350 for 18, $300 for 17, and $250 for 16. Compute the total project cost for each duration, plot the total direct, indirect, and project cost for each of these durations on a cost time graph. What is this cost? What is the optimum cost time schedule for the project? So the information given is activities, normal time, normal cost, maximum crash time, and crash cost. And this is the activity diagram with the critical point of A, B, E, G, and initial project duration of 19 and total direct cost of $470.
Can you show your answer is still the first slide?
Oh, I'm sorry. Okay, so the first step, we need to, okay, let me tell you first, the cost time solution is only focus on crashing on the critical path to shorten the duration of, to shorten the overall duration of the project. So based on the information given, the critical path we got is ABEG with the initial total direct cost of $470. So based on this critical path, we need to choose among of this activity which one has the least crash cost. So A has the least crash cost, which is $20, and the maximum crash time is 1. So if we crash the activity A, it will become 2x. Okay, so in this period, the total cost will be $490 due to the additional cost of crashing project A, which is $20. So the project duration reduced by 1, which is 18. So in order to identify whether we can crash any activities furthermore, we need to identify the critical path again, which is ABEG. The project duration is 18. So among ABEG, we can no longer crash activity A because it has reached the maximum crash time. So we need to choose choose activities either from B, E, or G, and E has the least crash cost, which is 50, and the maximum crash time of 3. So if we crash activity of E, it will become 5. So at this period, the total cost will be $540 due to the additional cost of crashing project A and project E, which is $20 and $50 respectively. And the project duration will become 17. So as I mentioned earlier, we need to identify the critical path again to indicate whether we can crash any activities further. So the critical path this time will be ABEG, ACFG, and ADG due to all of these paths share the same project duration, which is 17. So I would like to emphasize here, if we tend to crash any of activities from B, C, E, or F, it will not become the critical path anymore for A, B, E, G, and S, C, F, G. And the critical path after that will only be for A, D, G. And the cost time solution is, the point is, they need to crash the critical path to shorten the overall duration, right? So we need to select G, which is the crash cost is 70 and the maximum crash time of 1. So if we crash the G activity, it will become 4x. So at this period, the total cost will be $610 with the additional cost of crashing of activities A, E, and G, which is $20, $50, and $70 respectively. So the project duration will be 16. And as we can see, the path of ADG, as we can see, the overall, the ABEG, ACFG, and ADG are the critical path. But ADG, both activities of A, D, and G has reached its own maximum crash time. So we can conclude that the project cannot be crashed to any shorter duration anymore. So the next step is we tabulate the data from each of the project duration that we've done in the past. So we do have initial duration of 19, and it is decrement by 1 for 18, 17, and 16, and so on. Okay, the total direct cost we get is from the total cost at every period for every project duration. The indirect cost is the value can be obtained from the question, and the total cost is the summation of total direct costs and indirect costs. So in order to choose the optimum time cost, we need to choose the lowest total cost with the shortest project duration. So the lowest total cost, we have $840, but $840 is the value of project duration of 18 and 17. It has two project duration that we need to choose. So we choose 17, project duration 17, because as I said earlier, we need to choose the lowest total cost and the shortest project duration. So this is the project duration graph, which contain the data of indirect cost, direct cost, and total project cost. So the optimum cost time point is in 17 weeks and at $840, because we need to choose the shortest duration with the lowest project cost. So we can conclude that the optimum duration is 17 weeks at cost of $840. So that's all from me.
But
Thank you.
You didn't draw a graph. Where's your graph? You only have the listings only, but where is the graph? The graph to show
I'm not showing you.
Yeah.
This
Okay.
one.
Yeah.
This one. I'm so sorry, doctor.
Yeah. Okay.
Okay. So
great.
yes, this data.
Yeah. Very good.
Okay.
Very well explained. That shows that you really understand how to do the crashing of the timeline to the optimum point. Very good. Excellent. Okay, good. Thank you.
Okay. Thank you, doctor.
Okay. Can I ask TG5, T3 is the presenter here? What about TG5, T3, the leader is the leader here? Okay, if no answer, I assume that no one from TG5, T3 here. Okay, if that's the case, I will, because afternoon I got this TG5 session, so I will tell the TG5 leader to assign another presenter if the presenter is not around. Okay, so thank you. We will stop here first. Probably this question will answer on next Wednesday after my last lecture. Okay, so that's all for today. So if any question, anyone want to ask any questions? No? If no, then I will stop here. Then I will continue with afternoon session. So I'll see you on next Wednesday. Thank you very much. Okay, bye-bye.
Thank you, doctor.
Thank you, doctor.
Okay, welcome.